Hello, everybody. In this video, we are going to start the fourth chapter in the textbook, which is the chapter that covers the fundamentals of material balance or of mass balance. And we're going to cover the whole chapter, almost the whole chapter, with exception of very small parts. And this chapter is a very, very important chapter because uh, it gives all the basics of mass balance that we need as chemical engineers. In this chapter, we will learn how to classify different processes based on their nature, either batch, semi-batch, continuous, transient, and steady state. We will go through all these terminologies, which are very, very important terminologies. We will then learn the general mass balance equation, which is the basic equation, the conservation of mass equation that we will use to express any process or the mass balance or do the mass balance on any process, and then to draw a simplified flow sheet and to apply the mass balance equation on a single unit. So we will start with single unit, and we will know how many balance equations and how to solve these equations. And then we will move to the degrees of freedom analysis as a tool that we will use to know if the information that we have are enough or not. Then we will do this for multi-unit system. And later we will learn about the recycle and the application of the mass balance in case of having a chemical reaction, which is or requires a different way of applying the equation to account for the chemical reaction. And finally, we will cover the combustion as one special case of the reactions that is very, very common. We will start with the first thing, which is the process classification. And in this part, we want to focus on the nature of different processes. Not all the processes are the same, and we will see two ways of classifying the processes. One way is based on the flow of components, how the components flow, do they flow continuously or not, and the effect of time. Do the parameters change with time or not? So for the first thing, which is the flow of components, we have three types of processes. We have batch process, continuous process, and semi-batch process. So for the batch process, it's a process where, or let's go a step back. So when we talked about a process in chapter 3, we said a process is any series of operations where we have a feed that is fed into this process. Transformations take place, and the feed is turned into a product. So this is the definition of a process. And here when we talk about the flow of components, we mean the flow of the feed into the process and the product outside the process. So for a batch process, we have a feed that is fed once into the process, and the process takes place. All the steps and the stages are taking place in the process. And then after the process is done, after some time, the product is removed from the process. So during the process, there is no flow in or flow out. It's only the process taking place. The feed is fed in the beginning, and the product is produced at the end. So an example of this batch process is the washing machine. So in the washing machine, you put your laundry inside. Once you open the door, put all what you want inside the washing machine once, and then the process takes place, the washing, the drying, and all these things. And finally, after the process is done, you open the door, take the clean clothes out of the washing machine. So the process takes place. While the process is taking place, you cannot put anything inside or take anything outside. Of course, there is water that flows in and out, but here we focus on the feed and the main product. So the product that we want to get is the clean clothes. So you cannot get this product until the process is done. One other example is the pressure cooker. This is one kind of pots where you put the food inside. You close it tightly. You make sure that there is nothing you put inside, or the food doesn't come outside of this vessel until it's fully cooked. So this is a batch vessel. The equivalent to this in the industrial scale is the batch reactor. So the batch reactor is a reactor where you put all the ingredients or all the reactants inside. You let the reaction takes place, you mix them, you do all the or adjust the conditions until the reaction is fully completed. And once the reaction stops, you open the reactor and take the products out of the reactor. This is very common in case of the soap industry. So if you want to make soap, or in the process of making soap or making detergents or making shampoos, and all these things are done in batch reactors. So this is the first thing, or the first case, which is the batch process. The second is the total opposite, where we have continuous flow in and continuous flow out of the process. And there are many examples. The example here is the small air compressor that we use with the fish tank. So for the fish tank, we need to have a continuous supply of air to renew the oxygen in the water. So this compressor, it continuously, as it's working continuously, uh, sucks air from outside. So this is continuous feed, and continuously pumps air outside. So this is the continuous flow out. So the continuous flow in and continuous flow out. So it has to be continuously working, or this process is a continuous process because we have continuous flow of air in and continuous flow of air out. Um, this is similar to the air conditioner. It's similar to the pumps of water. So they all work the same way. The second example here is the heat exchanger, which is a very, very, very common equipment that we use in chemical engineering processes, which is used to exchange the heat between a cold stream and a hot stream. So we're looking at a very simplified form of a heat exchanger, but there are two pipes. They are concentric pipes. One is inside the other, and in this case, the cold fluid is flowing in the inner tube, and the hot fluid is flowing in the outer tube, or the annulus between the inner and outer tube. And while they are flowing, the heat is transferred from the hot stream to the cold stream. So this is why we call it a heat exchanger. In this kind of equipment, the flow must be continuous. We have a continuous flow of the cold fluid in and out of the heat exchanger, and a continuous flow of the hot fluid in and out of the heat exchanger. One last thing is the distillation column, and this is used to do or to separate components based on their volatility or their boiling point. So the more volatile components that have low boiling point will evaporate easily, so they will be collected in the top. And the opposite is or the opposite for the hot components that, or the less volatile components that have high boiling point, so we collect them from the bottom. So this distillation column operates continuously. We must have a continuous flow, or in general, we must have a continuous flow of feed into the exchanger, into the column, and a continuous flow of the top product and continuous flow of the bottom product. The semi-batch process is what we cannot consider as a batch or continuous. So it might be some process where we have continuous feed and no product, or not a continuous product, or vice versa. So for example, we have here filling a cup. You have a continuous flow in, but there is no flow out. So filling the cup, filling a tank, or whatever. So the process of filling a container is, of course, a sealed container. So it doesn't produce anything from any opening. In this case, it is a batch process. We have continuous flow in and no flow out. For the chocolate fountain, we put the chocolate once, and it continuously produces this chocolate that you can use. So it's a batch process. You have a semi-batch process. You have the feed is fed once, and the product is continuous. The same for the popcorn machine. In the popcorn machine, we have the corn put in the machine once, and the product is continuously produced from the machine, which is the popcorn. So there are other examples in industry, like the crystallization of sugar from sugarcane juice. So to make the sugar, or to crystallize the sugar, we put the this is one type of crystallizers, but anyways, we put the juice in a container. We adjust the pressure, we adjust the temperature, and evaporate the water until it starts to form crystals. So we put the feed once, and then the product comes continuously. There is the getting salt from seawater. In this case, we put all the well, I'm not sure if this can be considered batch or semi-batch, but we fill very wide areas with seawater and let the water evaporate, and then finally we get the salt. So we make the feed, or prepare the feed once, and then we get the product at the end. Anyway, so this is what we call a semi-batch process. For the second way of classification is the changing of parameters with time. There is a very famous term which is a steady state process, and the opposite, which is the unsteady state process. So steady state process, it's a process where parameters do not change with time. It doesn't mean that the parameters are always constant in every place in the plant, but it means that in a specific part of the process, if you check, let's say, the temperature, the pressure, the concentration, any one of the parameters at one point, now, and after 1 day, after 2 days, after 1 month, after 2 months, it would be the same. So it means that the temperature, the time is not affecting the parameters. They are adjusted to be always constant. So this is what we mean by steady state. If there is a change in parameter with time, it's called an unsteady state or a transient process. Steady state is preferred if we have a process that is continuously producing the product, and to make the product consistent without significant changes in the conditions of the product, we prefer to operate in or under steady state conditions. And of course, to maintain the steady state case, we have to keep monitoring and controlling the parameters. So we have the controllers, and we have sensors to make sure that we know that the conditions are always maintained as designed. The unsteady state is very common in case of startup or shutdown. When we start the plant or the process in the very beginning, and after we stop the process, it takes time to reach the steady state. So this is the transient or the unsteady state conditions. So this is what we want to discuss regarding the classification. In the next video, we are going to start talking about the general mass balance equation. We will see what is the equation that we use to describe any process, or the mass flow in any process. And then we will go into more details about the application of this in one unit and multiple units, and reactor systems and non-reactor systems. So I'll see you next time. Goodbye.